Okay, so as I said, I have a PhD in biochemistry, so not particularly useful in this. The reason why I have been invited to speak here is that I work for a small startup. We're only 12 people and only 3 of them are developers, so not a huge startup. But we work mainly in scientific literature, looking at how we can aggregate it, curate it, and summarize it to distribute it to a wider audience. I'm not here to really talk about that, but I'll go through it in a little bit because I think it might be relevant for what I'm trying to tell you today. The pitch that we submitted many months ago, and it's sort of somewhat changed as I've developed the talk, is thinking about AI for good. I think this is something that we were really roped into last June. So if you're involved in AI at all, you might have realized that the United Nations has the IT arm called the ITU, and they launched a conference back in June last year to talk about how we can make sure that all the nations around the world are cooperating together to make sure that AI continues to be an ethical practice and we're not essentially being biased with the data inputs or anything else in terms of the algorithms. So we sort of used that as a theme back in the day, and it's in the last year or so become quite a big public issue. I think with all the difficulties around Facebook and Google and where they're using their data. But that's not really what I want to focus on today. I'm trying not to have a political debate here. Main thing I want to cover is sort of thinking about recommendation systems, some of the ways that we've been trying to approach them at Sparrow, and hopefully getting some of your recommendations in the audience as to how we can move forward, because I think the recommendation system side of things is really one of the biggest things that has touched the consumer in the last decade or so in terms of actually seeing machine learning put to use, from Netflix to Amazon to, essentially buying socks. So let's get going. So I'm going to try to make this really short because we obviously spent a lot of time trying to find an adapter. So what to expect, I'm going to start with a little bit of an icebreaker. Hopefully we can crack you up a little bit. I'll do a little bit of a background on Sparrow, and then I'll run through actually what I want to go through, the main topics I want to go through. And then there's Q&A, but I won't be able to answer anything technical. Just going to put that out there. So I think the big question here really is what sort of information you would trust if it were recommended to you by a machine. I think this is more so a question that a consumer has to ask themselves. Whether I'm seeing an ad on Facebook or whether I'm looking at a recommended item in Amazon, or the next article that's being suggested to me through The Guardian or even like a respected news publisher. Where have they found this recommendation and why is it being served to me? So this is the really, really big question, I think, if we're going to be in data science and tackling this sort of stuff, we need to be thinking about. I do want to ask this to the audience. This is just a yes/no question at the moment, so let's just get a little bit more awake. So would you trust information recommended to you by a machine? One person. Okay, a few of it. Okay. And obviously that's a trick question, right? I think most people would then ask, obviously, what information, because that's a bit of a, nasty thing. So, I was just thinking about this. So, for example, there are a bunch of things that you can ask, the computer to do for you nowadays, or your phone or whatever, right? So, you might ask for routes to the airport. At this point, I'd probably use Citymapper. Wouldn't really worry too much about it. I'm looking for Thai restaurants around here. Probably use TripAdvisor or even just go onto Google. TV to watch tonight, I've got plenty of options. If I'm trying to look for sort of like tips to how to, say, improve what's going on at my startup, maybe I go to Medium, maybe I go to Quora. I'm looking for what's going on in the industry, I might go to LinkedIn, maybe Twitter. And if I'm looking for relationship advice, I probably wouldn't be using a machine. But that's sort of, just an illustration of what sort of categories the recommendation system is now sort of available to the consumer. Now, I think, from my perspective, there's a real dichotomy between the top 3 and the bottom 3. And for me, I think mainly is that the machine would need to know a lot more context about you to perform well in those situations. So I think, tips to improve how you work as a team, obviously, everybody can do some generic teamwork thing, right? But if you really wanted to get into improving specific areas of what you're doing, you don't really want to get the same, 5 ways to improve team morale, from LinkedIn every single day from another random content marketer. So in this case, the machine needs to know a lot more about your context. Obviously, I don't think relationship advice is ever going to get there. So the real question here for us in the industry is how can we design AI that people can trust to recommend relevant information? And specifically, especially in our case, and I'll go on to why this is, specifically the context here is that the user has a very personalized reason for being there. You know, it's unlikely that you're going to find another user or a large group of users who are looking for information in exactly the same way. And then also it's difficult to define what they're looking for unambiguously. And this is one of the things that we've been doing at Sparrow a lot. You know, if you're trying to find something science-related, generally you need to know exactly what term you're looking for. So I used to work in biochemistry, so you know, it was easy for me because I knew exactly what gene or whatever protein or whatever methodology I was looking for. However, if you are completely out of the field, if you don't even have the keywords, it's very difficult to then specify what you're looking for, and very difficult to specify to a machine what you actually want. So that's really the field we work in at Sparrow. And this is also, I think, quite important to a lot of other fields aside from science. You know, when we're talking about news or when we're talking about any other sort of essentially advisory information on the internet being recommended, you know, there is a similar question there. So let's take Sparrow as an example. I'll say a little bit about our vision. In our view, our founders and our team believe that all scientific information can be presented at the right level to the right person at the right time. Now, obviously, we're not at that state yet. Most scientific information is being presented in papers, which are accessible through specialist databases. You can find them on Sparrow, but generally that's, you know, pretty difficult to parse. For us, that's a real problem because we believe science should be available to all. And scientists need time and the tools to communicate to non-specialists or even people outside of their own field. And this information overload we've seen, or this inability to communicate to other disciplines efficiently, means that there's a real hindrance on actually the application of new findings. I'm not even talking about, you know, progressing the academic prowess of the humankind. I'm just talking about applying stuff we found out 10 years ago. Seems pretty tough, so. And you know, we're looking at, specifically, again, I'm just using an example from my own field, but biopharma say, you know, we're looking at the top 12 pharma companies. Their returns on R&D spending have dropped from 10% in 2010 down to 3% in the last year. So, I mean, there's significant issues. You know, all the low-hanging fruit have been picked, essentially. So we need to start thinking more multidisciplinary, and we need to think more about how we can actually get the R&D spending to turn into some dollars. This is really something we believe at Sparrow. And we think that a big part of it is actually the communication of the science. So just to give you a bit of a feel of what we've been doing, we kind of broke it down, the problem, into 3 parts. So we thought aggregation is a big important thing. So, you know, having all of the sources and all of the papers in a single place with a standardized database that we can actually analyze and do interesting things with, pretty important. So we started with aggregation. Then we've been doing curation. You know, with the people who've been searching for stuff on Sparrow, and we have sort of tracked searches or alerts or whatever you call it, a lot of people have wanted to bookmark what they've been looking at. So they've actually, organically, we've built this idea of a pin board for them to save these different categories of papers that they feel belong together, little libraries or collections, different platforms have different names, we call them pin boards. So we've collected over 128,000 collections now, and these are from scientists around the globe. And then the final step that we're doing right now is looking at summarization, because what we find is that the main hurdle is not still finding the papers, it's actually understanding the context around the papers by the time you get to it. So that's still a big hurdle. Summarization I wouldn't count as part of the recommendation engine. You know, it's a complete side project for us, and it's a sort of a different research branch in a sense, trying to think about how we can summarize, say, you know, 20 papers down into at least a paragraph where we can signpost where all the different stats come from. But that is part of, in our sense, in our view, a whole journey of how we can essentially make science more accessible to all. Now, going back to recommendation, which is what I want to focus on, we're hoping to essentially draw different data from each of these different steps to build a more powerful recommendation engine. From the aggregation, we're really looking at just analyzing content similarity. So from a recommendation perspective, if you've worked with recommendation engines already, then we'd be looking at sort of item-based similarity. We're just, you know, matching like for like. Whereas with the curation, it starts to get a little bit more interesting because we can actually look at what users have grouped as interesting, relevant things. So then we can look at collaborative filtering, look at different users who are actually looking at the same things and maybe recommend them a similar thing that they might not have considered before. And with summarization, at the moment, in terms of the recommendation side, we're seeing that sort of extracting keywords or trying to extract new terms from the way people are talking about maybe older science. So they're actually renaming terms or renaming fields altogether based on what's happened lately in the field. That's quite interesting for us. So from our side, we're trying to build a recommendation engine that captures all three things. And we have this community aspect which helps us bring in some of that human input. So this is sort of an overview right now, and I want to go into the key question, which again, just to reiterate, is how do we design an AI that people can trust to recommend relevant information? Specifically for us, it will be the scientific information. So naturally, because we are a scientific literature platform, we tend to read quite a lot of literature in our spare time. So one of my little hobbies is to read literature around recommendation systems. I'm not a computer scientist, but I try to understand as much as I can. So if I'm wrong, please let me know. I would love to get some feedback, actually. So I think there are 5 things that I've been reading so far, which I think are really like trends that I would like to see more of, essentially, coming out of the research community in terms of how we can make recommendation systems better. There's a great intro, which was really great for me, complete beginner. It was written in 2010, but I think it's still a good intro for everybody. All of the papers you can find later, so I will have a link for you guys, so don't worry too much about it. So the first suggestion is that from our side, and this is also something that we currently plan to do, is that 10 seconds or 10 minutes? Minutes, cool. Just checking. Cool, so I can run through this quickly. We're trying to incorporate high quality human input creatively. I know in terms of like data sets, usually we're looking at like what, thousands, tens of thousands, or like millions, hopefully. But at the moment, it's going to be hard. With the curation also, if you have a large spread of completely different things, so we have currently 60 million items in the database. We have around 400,000 monthly visitors, but the probability that they all traverse the same sort of path in the graph is really quite low. So in a sense, we've kind of all got like, 1 or 2 visits or like 3 visits per month on a paper. So it's not really a great deal of data we can get. But we're trying to incorporate sort of this sort of human input, any human behavior, we're trying to incorporate it creatively. One of the papers that we were reading recently was that researchers were trying to essentially pick out more of the trust side of things and try to pick out either smaller communities that they could identify as having shared interests, so that if the individual doesn't have a huge amount of data, you can still group them in one sort of smaller sub-community that you can approximate. And then another one said that a lot of, in terms of thinking about trust, sometimes people model it very much as like an equal relationship. So if I trust you, then you trust me equally, and that's like the simplest way to do it. But if it's in the case of, say, a researcher, and I trust that this researcher is a specialist in his field, I don't expect him to naturally think I'm also an expert. So that sort of stuff is getting involved in thinking about the recommendation system. Actually, if you're trying to measure these social networks, it's directional often, and it's not just a simple, okay, he's a friend of that friend, and then, they were collaborators, or, very simple matches. So I think at the moment that's something that we could certainly look into doing better. Second suggestion. So this was something that was sort of more alarming than anything. We were reading some papers about more of the popular sort of off-the-shelf recommendation systems. Most of the recommendation systems that you can get off the shelf really are for e-commerce, so, buy this skirt if you've bought this handbag. And so one of the things that they did point out when they were looking at the empirical data was that the accuracy metrics didn't really align with the user benefit. So accuracy in the recommendation system is more about sort of matching the user's preferences. But often, because the people who buy these recommendation systems are the marketers or the salespeople, they're on their side, on the back end, maximizing for profit or maximizing for essentially volume sold. So what happens is that they just keep selling the top sellers. And this is obviously something we are looking not to do as part of our platform. We're not just trying to recycle the most cited article again and again so that everybody clicks on it. We're trying to make sure that everybody finds the thing that they want, as opposed to just creating something that's more and more popular. And if you're in the academic field, you'll be aware of something called impact factor, which is essentially a sort of positive spiral where if you get cited, then more people cite you, and then your impact factor goes up in the journal, and then everybody wants to publish in that journal, and then essentially it's just the more you get cited, the more you get cited, which is not really particularly useful if we're trying to understand quality of research. So just being aware of off-the-shelf solutions. And then from our side, we specifically choose to promote long-tail results. If you're not aware of what long-tail means, it's just sort of like, you'll have essentially 80% of the stuff will be viewed a lot, and then 20% of the stuff will give you most of your traffic, and then your last 80% will just have like mild traffic. And then, they'll be completely niche and completely random. And we see that also with our pages. We'll have a lot of different areas which are completely unheard of. But it's possible to choose to promote that, and it's actually really important that you do, because you want to introduce diversity and novelty into your recommendations. You don't want to just keep showing them exactly the same thing. And I think one thing I would say is that I've noticed with YouTube, say, they used to show you more stuff relevant to the video you were watching, as opposed to your history. Whereas nowadays, they just, essentially it's all the things you've subscribed to or people you know. And then so your recommendations keep becoming the same things over and over again. And, it's not necessarily relevant when you're watching something different to what you usually watch. So there's something to look out for when you're looking from a user perspective. This is pretty obvious. This is a new study that came out, so you can actually take a look at their methods and just take what they've done. Don't recommend out-of-date items. I think a lot of people don't factor into the fact that people change their minds over time. So something that was interesting to them even last week isn't interesting to them this week. So making sure that you understand what the user's sort of time decay is for interest. And then finally, this is new. I would say this is pretty new. I haven't really seen anybody do this well yet. But really working the explanation into the back end of the system, trying to actually be really clear about why you've been recommended something, and then show that on the front end. Connecting those two things together, I think, would be really helpful. And also, I think, hopefully, reduce some of that mistrust between what the computer is doing and what you're getting. Because sometimes you don't know. I mean, suddenly I'm getting ads for a pair of trainers which I never looked for. So where does that come from, right? So that's pretty much all I wanted to cover in terms of new literature we've been looking at lately. I know there's supposed to be some Q&A time, so I want to make sure that you guys get that. And one last note, which is just a UX thing. I'm really on the product side, so this matters to me a lot. In terms of recommendation engines, I think obviously the recommendations themselves are important, but the way you deliver the recommendations are really, really a big part of it too. One of the new things that has been talked about is the idea of conversational marketing or conversational interface, where actually you're not being recommended a list of things like you normally would, and you essentially get that nudge theory, sort of like the idea of having different choices and being pushed towards one choice or the other. But the idea that you're actually being in conversation with some sort of chatbot or some sort of system where you feel like you're actually getting a personalized recommendation on the spot. So potentially that's something that we can move to, or potentially it could be a complete scam, so look out for that. That's pretty much it, I think.